Part 3 of the classification of matter is going to talk about how to separate that matter when you have different types of mixtures together. So here's an example of kind of a complicated setup. It is the process of distillation. So if you look at the picture, you start off with heating up water, you generate steam. That steam then goes through the different contraptions, condenses water vapor, and then it comes out the outlets and into the lower flask, which is a distilled form of that water. So that all of that is a distillation process. So whenever you have substances that are mixed together, so you have a mixture that are physically combined, what you can do is you can take them apart. And there's different ways in which you can do that. So you can't have a substance that has been chemically reacted. It has to just be physically mixed together. So an example of that would be something like salt water or sugar water, or if you're trying to make some kind of an alcohol, or there's a bunch of different options. If you're trying to make candy, there's a different procedure for that as well. So when you are taking substances that are physically combined together, not chemically, and you're trying to separate them into their individual components. So there's a bunch of different techniques. I'm just going to talk about 4. There are a lot more than that. I'm going to talk about the 4 most common practices of substance separation. And those 4 are filtration, distillation, crystallization, and chromatography. You've probably heard of filtration and distillation. Those are very common. Crystallization, not so much as common. And then chromatography is definitely very specific. So the first one, filtration, I use this process every single day when I make my coffee. So what you do is you take a mixture that is physically combined and you separate it through a filter. I use coffee filters, and then you end up with that substance left over that you're trying to get out. So as far as the coffee goes, I don't want coffee grounds when I'm drinking coffee. I just want the caffeine and the flavors and all of that to come through, but without the coffee grounds. So in chemistry, we filter out what are called precipitates, which is just a word for solid. We filter out precipitates, and then we can figure out how much of that precipitate we produce, which is really important. And what it does is just separates what you don't want and then what you do want from that heterogeneous mixture. So this is generally used, filtration is generally used when you're trying to get a solid out of a liquid. You have to use the porous barrier, which would be the filtration or the filter. And when the liquid passes through that barrier or the filter, it leaves the solid behind in the paper. It's the best way to get a solid out of a liquid. The next one is distillation. This process is very widely used in the alcohol business, so whether it is rum distillery, beer, spirits, whatever it is, wine process, all alcohol beverages have to be run through the process of distillation, and so does water more often than not. So it's used to separate homogeneous mixtures. So generally when you have liquids mixed together, and it's based on, this is really interesting, it's based on different boiling points. So if you have 2 substances that are mixed together, 2 liquids, that have different chemical properties, so they have different intrinsic properties, you can heat up the mixture to reach the boiling point of the substance that you're trying to remove, but not the substance that you don't want, or vice versa. You can boil it so then it turns into vapor, and then it condenses down into a different tank, and then that tank is used to then purify the substance, and then that's what you would drink. So the intrinsic properties are extremely important in the process of distillation. Another one is crystallization. Crystallization is used when you have, when you're trying to form a solid. So a natural example of this would be snowflakes forming. And a man-made version of crystallization would be if you're trying to make rock candy, or basically any kind of candy. Anything that's you're taking liquid sugar and you're solidifying it, that's the process of crystallization. So you're trying to form a pure solid from a liquid solution. And there's your rock candy. The last type of separation of mixture is called chromatography. Chromatography is a little bit more complicated, but it also has far-reaching practices. So chromatography has been used in doping scandals. So when athletes are using drugs that they're not supposed to be using so that it can enhance their performance, you can test for that. Well, one of the ways to test for that drug, or whatever the drugs they're testing for, is through the process of chromatography. The Ebola outbreak that happened recently, they also used the practice of chromatography to determine what antibiotics the Ebola was resistant to. They can also use it in forensic testing. So forensic scientists who work in police stations, say if there's a crime and there's blood left at the scene, forensic analysts can use the process of chromatography to test that, and then you can also use it in the agricultural world if you're testing for pesticides in the groundwater. So it's used a lot of different ways, and you can see in the picture that the colors are separated, so you can see red, you can see blue, green, and yellow. So chromatography is just the separation that occurs on a piece of filtration or a filter paper, and it's based on an attraction force. So the red, blue, green, and yellow are different components of whatever that substance is on the paper, and it's attracted differently to the solution. You can see that it's wet to the solution that's on the paper. So you're separating the mixture based on basically the attraction force of each of the different components in that mixture. So again, we're going to talk a little bit more about the separation techniques of mixtures, but as of right now, that's the end of part 3. In part 4 of this series, we're going to be talking about what happens during chemical reactions and when you physically change a substance.